today's lesson, section 5.4c. We'll still be talking about more trig graphs. Here we're going to apply period, phase shift, some period changes to our cosecant and secant graphs, just so you can kind of see how they stretch and move. Remember, the same thing applies to cosecant and secant as the other ones do. When you have stuff like this inside the parentheses, 2x plus pi over 2, to figure out your correct phase shift, you need to factor out those values. So if I factor out a 2 dividing, so 2x divided by 2 gives me x, pi over 2 divided by 2 gets me pi over 4. Okay, so now I have the correct phase shift, which is moving it over to the left, pi over 2. Okay, so now I can apply that to my x-axis here. I'm doing the table one. Okay, on the next example, I'll do the transformation one so you can see both. Okay, so here, if I have 0, now remember I'm only looking at this first part. So 0, if I want to keep this at 0, then that means negative pi over 4 plus pi over 4 would give me 0. So that value's got to be negative pi over 4. Okay, that's where the opposite comes from. Okay, so it wants to move it to the left, pi over 4. Then here, now it would be still the same thing to get that first one, but now because you have a 2 there, since our period is pi over or 2 pi over k, you insert your pi or your k in. So that's 2. That gets us pi. So pi divided into fourths should be pi over 4. So we should go every pi over 4. So if I add pi over 4 to negative pi over 4, that gets me 0. Okay. If I add 0 to that, that gets me pi over 4. Add pi over 4 to that gets me pi over 2. Add pi over 4 to that gets me 3 pi over 4. Okay? And so those should be my new x values. Okay, so now I'm going to plug those into my cosecant function. Remember, we're looking for those same values that we had in the last video, where you're going to have undefined lines and 1 and negative 1. So if I plug in negative pi over 4, that gets me negative pi over 4 plus pi over 4 is 0. 0 times 2 is 0. So cosecant of 0, remember that's the reciprocal of sine, so that was undefined. So we should get an undefined line at negative pi over 4. If I plug in 0, 0 plus pi over 4 is pi over 4, times 2 is pi over 2. And then cosecant of pi over 2 is 1 over the sine of that, which is 1. So cosecant of pi over 2 is 1. 1 times 1/2 is 1/2. Plug in pi over 4. Pi over 4 plus pi over 4 gives me pi over 2. Times 2 is pi. Cosecant of pi, remember, is also undefined. Okay? Then pi over 2 plus pi over 4 gets me 3 pi over 4. Times 2 is 3 pi over 2. So cosecant of 3 pi over 2 was negative 1. Negative 1 times 1/2 was negative 1/2. And then 3 pi over 4 plus pi over 4 is pi. Pi times 2 is 2 pi. Cosecant 2 pi is undefined. Okay? So we should kind of get those kind of looking values. So I have an undefined line at negative pi over 4. I have another one at pi over 4. And I have another one at 3 pi over 4. Okay? So I'm only graphing one period of this. So at negative pi over 4, and then remember 0 was 1/2. And just for namesake, let's make this 1 and make this negative 1, so we can get our scale to look a little nicer. And then at pi over 2 is negative 1/2. Okay, so remember that our graphs are going up to our vertical asymptotes, or approaching, but not crossing. Okay? And so that would be my graph. Okay? Pretty simple, right? So, next example. Now here I'm going to use transformations. So, for 3 secant of 1/2 times x minus pi over 6, here your phase shift has already had then the k value factored out, so you don't have to worry about it. So let's graph secant of x first. So secant of x, remember, was 1 at 0. At pi over 2 is undefined. At pi, it was -1. At 3 pi over 2, it was undefined. And at 2 pi, it was 1. So then you get the picture that looks like that. Okay? So then from there, now we want the secant of x minus pi over 6. So that means I'm moving everything to the right, pi over 6. So that means this value's pi over 6 over. All my undefined lines move over a value of pi over 6. That moves over pi over 6. 3 pi over 2 moves over pi over 6, and then that moves over pi over 6. So then we get a picture that looks like that. Okay? So that one's moved. Then we're applying a k value of 1/2. So remember 2 pi divided by k. So our k is 1/2. So that means the same thing as multiplying by 2. So then I get 4 pi. So the distance between each thing is a measurement of pi away from each other. So our first value is going to be at the same spot, at that pi over 6. Okay, nothing changes. Now from there, I want to go another pi away to that for my undefined line. So then a pi away from pi over 6 would be 7 pi over 6. So it'll be right there. Okay, another pi over 6 would be 13 pi over 6. So it's just the next one past 2 pi. Oop. Put the wrong thing in there. It should be -1, right? Okay. Then another pi over 6 would be that undefined line at, I believe that would be 13, so 19 pi over 6. And then at our last one, it's all the way over here, can't quite get it onto the picture, but it would be 1 more than 4 pi over 6. So you got 25 pi over 6. Okay. So make our graph. Now we really elongated it. Okay. And then for the last one, we want to multiply everything by 3. Now this one's going to be kind of hard to do. Now nothing moves. Okay, so your asymptotes are still at the same spot. All your points, other than actually, that would be the one thing that would move, would be those values. So we go to 3. But other than that, nothing really changes here. 1, 2, 3. Okay, so then now you have your new points. And they should get steeper. But that might be hard to do because you don't have other values to reference. But just make sure that your lines approach your vertical asymptotes for your picture. Okay, so the red would be your final answer for this one. Okay, have fun.